to the nitrogen system Overhaul by Overhaul Consultants Incorporated. Let's take a look at the current situation of the region of nitrogen. They face two significant problems. One is acidification of the soils in natural areas through the atmospheric deposition of NH3, which they aim to produce with the ambitious percentage of 90%, and secondly, the contamination of the groundwater in the region with nitrates through the leaching from agricultural soils, which they aim to produce by 75%. This part, all the while remaining their food import at zero. How we will do this? We will both take immediate measures that can be implemented right away, and we'll tackle the problem at the root by two measures that affect the fertilizer use, which is really at the root of this problem because it creates surplus nutrients that leach into the ground. So first we'll lime the soil, we'll introduce calcium into the soil, which makes the soil less acid and makes it easier for crops to uptake essential nutrients. It will increase the efficiency of the fertilizer use and therefore create a less acidic environment. And to source this calcium, we are going to create industrial symbiosis with the sugar beet industry that has a surplus of this. Second, we will eliminate the fodder import to stop the overnitrification and also to stop the soil degradation in the countries where this fodder originates, all the while reducing a little bit both of our targets. Then thirdly, what we will implement, because we really need to do something about the atmospheric deposition, that is this problem. And therefore, we're going to install air filters in stables at an efficiency of 95%. This is very effective in eliminating the problem of atmospheric deposition, and the waste of these filters shall go into the landfill. So here we have our immediate measures, but really we need to also tackle the problem at the root and still solve the problem in our groundwater. And so we're going to need a new way of using fertilizer, which we'll do in two ways. First, by introducing green manure. These are crops that have already been uprooted. These dying plants become organic cover crop to add nutrients and organic matter to the soil. They take only 2 months to seed. They grow as grass, no fertilizer, pesticides required, just some water. And this makes great sense for nitrogen filtration because the nitrogen leakage is reduced 30 to 50% over the course of 3 to 4 years because of a reaction between the soil bacteria and the roots in the cover crops. And also what these crops do, they have deep roots that go deep into the ground and they bring up nutrient resources to shallower ground for the crops to uptake. Decomposition of the plants allows for reincorporation also of other nutrients, as we see here, and it also attracts beneficial insects and increases water infiltration. So many benefits that also make great economic sense. As we can see here, for example, for the corn, the seed cost for the cover crops is $35 to $50 an acre, and it increases the corn yield it increases the corn yield, and same goes for cotton, which also seed cost is the same, and here you can also see the increase. This provides a long-term solution that reduces fertilizer cost by 75 to 90%, all the while increasing yield. So this also greatly benefits, and then we can minimize synthetic fertilizer in combination with the last measure we will take, which is the treatment of the animal manure. So we can further decrease the surplus nutrients we have. We create a new process in which the animal slurry, which we will store in better containers so that nothing is leaked to the ground anymore. This separation will take place. We get organic fertilizer and concentrate minerals that we can use directly as fertilizers on the crops to completely eliminate any need for synthetic fertilizer. And then we also have water, permeate water coming out of this process that we can use for the non-treatment of nitrate in water. We combine this water that has lower levels of nitrate with waters that have higher levels of nitrate until a safe quantity of nitrogen is reached. So, and we can also avoid the problem entirely by using another water source that's not contaminated. So here the process is in agricultural soil, less nitrate is again reached into the groundwater. Finally, these are very ambitious measures, and it will require a real system overhaul to create this. So therefore, we are going to create some financial incentives for the farmers to actually switch to a different kind of fertilizer. Therefore, we're going to subsidize the use of these organic fertilizer and at the same time increase taxes on the use and production of synthetic fertilizer. And we can then again use this money for the subsidy, but also to educate farmers on how to use the green manure and introduce the reverse osmosis process. And we'll issue a directive for the fertilizer industry to switch to these organic fertilizers so that these ambitious targets can eventually be reached. Let us see. So here, what is the results of everything we've done? Let's review this in this video. So first we are liming the soil, which affects the transfer coefficient of the agricultural process in agricultural soil. Then we're going to eliminate the import to zero. Both these measures affect groundwater and natural soil, but we need more measures. So we're going to install the filters on the stables, the air filters, which should drastically eliminate the atmospheric deposition into the ground soil. And we're going to put the waste of that process into the landfill, which we just created a flow, and now we're going to adjust the transfer coefficient so we have a 95% efficiency, and then the rest of the waste goes into the landfill from those filters. Then we're going to create next our green manure process. This will be a production process into which we need to import a new mass of nitrogen, which will be our green manure seeds. And this will really affect the system at its root level, because right now we still have way too many surplus nutrients going into the soil. So instead we'll switch to organic fertilization. We chose an import for green manure that's going to keep our food import at 0, and then create a flow from the green manure production into the crop grass production. And then we can reduce our fertilizer significantly to only 10, the synthetic fertilizer in this. And then we create our new process, the reverse osmosis, which is going to treat the manure. So the manure is now going to go into the treatment plant. It will be in enhanced storage buckets, and there's going to be a new process created also. That the first outflow out of the reverse osmosis is the organic fertilizer. And then secondly is the concentrate NK that comes out, which both also go into the crop grass production. Now we'll need to change our transfer coefficients for this process. We get more of the concentrate. We get about 60% concentrate, 40% in the ground. Then we have to change our transfer coefficients, and our green manure very efficient. And then also our organic fertilizer and our concentrates are highly efficient at 80%. So we'll set that to OK. Then because of our green manure, the groundwater contamination is even taken down more. Together with the treatment of the water we'll do, and you see, as we calculate, we see that we have met our objectives both in the natural soil and the groundwater, and our food import is at 0. So we see all our measures have been reached through both the immediate measures and the tackling of the root of the problem. It will require some incentives and it will require some effort, all for the benefit of the region of nitrogen. Thank you for your attention. Overhaul Consulting, Anne van Bruggen, Carl Koen, Rens van den Peppel, Milan Veselinov, and Jong. Thank you very much.